Right, so the first thing I wanted to do today is I want to show everyone how you can access my website and the past recordings online, because a lot of people have been asking about how to do that. So I'll share my screen. Okay, so you go to CCLE. Then on the site for our class, you can scroll down to my name, and then you see my website, and then you just go to teaching. And over here, if you click on these, you'll get links to YouTube that show our past recording. And over here, you can find the notes for each week. So if you click on Thursday, you get the Thursday video, for instance, from week 2. Okay, so does that make sense to everyone? Were people having trouble with that before? Great.
Sorry, wait, where was the link on CCLE?
So the link on CCLE was, let me share again. Here you see a list of all of the TAs, right? Some of the TAs, like me, have blue names. So the name is the link to the website. Okay? All right, great. How do I stop the sharing? Yeah. All right, so let's do some math. So first, can everyone use the method that I just showed you in order to get the course notes for today? To check that you are paying attention, because every week I usually post the Overleaf link in the chat, but you can go find it on the website. So can you go and get it off of the website? Okay, did people get the notes? Other people didn't, only 3 thumbs up. Great. All right, well, here's the link in case you can't, but let me get started. So because we had yesterday off, there was no lecture, so today we're mostly just going to be doing some review, and I've come up with a lot of problems for you to try that deals with this material. Okay, so first we're going to have a quick review of inverse functions. So recall that the definition of an inverse G, so inverse G of function f is a function such that f composed with g, which is equal to f of g of x, is equal to 0, or is equal to x, okay? And likewise, if you're taking the derivative, then if you want to find the derivative of an inverse function, you know that f of f inverse of x is equal to x, and therefore if you take the derivative on both sides, you get f prime of f inverse of x times f inverse prime of x is equal to 1. Remember, prime is just another way to say derivative. And then we can divide through by this, and we get f inverse prime of x is equal to 1 over f prime f inverse of x. So this is the important method for how you find the derivative of an inverse function. So using this method, I want you to try the following problems in your breakout rooms, okay? So first, find the derivative of ln x, find the derivative, so same thing, of sine inverse x, and 3, find the derivative of the inverse of f of x equals x plus 2 over x in 2 ways. First, you find the inverse function and take the derivative, and then after you do that, you use the method that I showed you before, the formula. So like 1 over f inverse prime, or 1 over f prime of f inverse of x, okay? So does this make sense to everyone? Great, okay. So I'll put you into your breakout rooms. It would be super great if people could not sit in the breakout rooms with their cameras off and not say anything, because then there's basically no point. So, okay. All right, so can I get some Fs in the chat if you managed to solve those problems? Or if you managed to solve at least 2 of them? Great, that's what I like to see. I'd also like to thank everyone who was talking in the breakout rooms and had their camera on. Otherwise, it's a pretty unpleasant experience for some people. Okay, so let's go over them. So we're just going to be using this formula that we derived a few minutes ago. For the first problem, what's the formula? So we want to take 1 over d dx e to the x, and just to make notation, I guess, simpler, we'll say composed with ln of x, okay? Because we want to take the derivative of e to the x, and then we want to plug in ln x, okay? Whereas if I put the ln x up here, then it makes notation a little bit more complicated because we're not taking the derivative with respect to the composed function. So, okay, this gives you 1 over e to the x, because that's what the derivative is, composed with ln x, and that just gives you 1 over e to the ln x, and that gives you 1 over x. I apologize for the board management. So, okay, does everyone agree with that? Is everyone happy with this? Great, thank you. So now let's do the second one. This one's a little bit trickier. So in this case, we're doing 1 over sine x, derivative of sine x, composed with sine inverse of x. And so this gives you 1 over cosine of sine inverse of x. And now I think a lot of people got to this point and then weren't sure how to simplify further. So there's a pretty standard trick that maybe you learned in pre-calculus, to turn this into the more standard expression for the derivative of arcsine or sine inverse. So what does it mean if we're taking sine inverse of x? What this means is you have some sort of right triangle, and how do you compute sine? Well, sine is computed, you got to remember your SOHCAHTOA, and you're taking the opposite over the hypotenuse. So it's good enough to consider a triangle where you have x as the opposite and the hypotenuse is 1, because then opposite over hypotenuse gives you x. And then we can fill in this side using quadratic, or using the fact that a squared plus b squared is c squared. And this just gives you 1 minus x squared root for the third side. Okay? And so what does this tell you? This tells you that if you have a triangle where sine of theta is x, then these are the sides. This is the ratio of the sides. And so then what's cosine of sine inverse of x? Well, that's just cosine of this theta. Cosine of this theta is adjacent over hypotenuse, and that's just 1 minus x squared root over 1. And so we get 1 minus x squared, and of course that's in the denominator. So sorry, this should be all over, that should be in the denominator, so then this is your final answer. Are people happy with this? Fantastic. All right, let's do the last problem. So for the last one, we want to figure out what the derivative of x plus 2 over x, the inverse of this function is. So before we go further, we have to find the inverse. So we flip x and y, and we get x as y plus 2 over y. And then we multiply through by y, we get yx equals y plus 2. Subtract y from both sides, and we get yx minus 1 is equal to 2. And then y is equal to 2 over x minus 1. So there are two ways to find the derivative. First is the straightforward way. So for the straightforward way, we just take the derivative of this thing. And then we get 2 over x minus 1 squared minus. So do people believe me here? Make a mistake? Are people happy with this? Oh yeah, okay, great. Thanks. Thanks for the thumbs up. Okay, great. So this is how we find the derivative using one method. And then for the other method, we can do the 1 over f prime of x, f prime of f inverse of x. And so for this method, we take the derivative of this, and that gives you, okay, so we have to use our quotient rule. So I think it's low d high. So that gives you x, d high is just 1, minus high d low. So that's x plus 2 times derivative of x, that's just 1. And then we divide out by x squared. And that gives us minus 2 over x squared. And then we plug in the inverse of this function, which is 2 over x minus 1. And I'm a little bit scared that I made a mistake here. But this gives you minus, so okay, we have 2 over x minus 1 squared. And that gives you minus x minus 1 squared over 2, because we get a 4 here. And then we just put that in the denominator. So we get 1, that goes to 1 over x minus 1 squared over 2, and that's just minus 2 over x minus 1 squared, and that's your answer. Are people happy with this? And note that these two match. Great. Thanks. All right, so let's go on. So the next very important thing is L'Hopital's rule. So it's spelled L'Hospital's rule, but this is pronounced L'Hopital. And so the idea behind L'Hopital is if you are taking the limit of some function, f of x over g of x, and the function, both the numerator and the denominator either go to 0 or infinity, then one way that you're able to find the limit is by computing the limit instead. So lim x goes to a. And remember, x doesn't have to go to 0 or infinity, just the two functions do. So then we get f prime of x over g prime of x. Lim x goes to a. Okay? So one thing that many students screw up about this method is remembering that the top and bottom must go to 0 or infinity. If not, here's a counterexample for how L'Hopital's rule breaks. So consider the function 3 over 4 as limit as x goes to 1. So of course, these are constant functions, so it doesn't matter what x goes to. If we take the derivative here, we end up getting 0 over 0, which is not defined. And so this clearly is not correct. So this is bad. Don't do this. Okay, great. So let's do a few examples. Thinking about which ones from my worksheet are best. Yeah, okay, so does everyone have my worksheet in front of them? Great. So on my worksheet, let's start with number 4, and then if we have time, we'll go back to number 3, because I think the problems in number 4 are better. And just in case you don't have my worksheet, I'll put you in your breakout rooms, but then I'll start writing them here. So if you can't find them, you can either get them from someone else in the breakout room, or you can look at my sloppy handwriting. All right, and again, please try and keep your cameras on and talk. Otherwise, the breakout rooms are absolutely useless. Okay, so can I get either thumbs up or Fs in the chat if you're happy with those problems? Not too many people seem happy. Okay, we'll go over them. So for the first problem, this is actually very important because it's used all the time when you're taking limits, because you don't want to recompute this every time. So we want to show that x to the n grows more slowly. So one way to write this is like this: grows more slowly than e to the x. One way to do this is by computing x to the n over e to the x limit as x goes to infinity. And so then we just do L'Hopital's rule, okay? So we check, do top and bottom both go to infinity? Yep. So then we do, we take the derivative and we get x at nx to the n minus 1 over e to the x, because derivative of e to the x is just e to the x. Then we say, okay, do top and bottom go to infinity? Yep. So then we take another derivative, and we just keep doing this until the power here goes down to 0. And so that means we're going to get n factorial in the numerator times x to the 0, which is 1, over e to the x as limit limit as x goes to infinity. And so the numerator n factorial is big, but it's not nearly as big as e to the x as x goes to infinity. So then we just get 0. So that's all you have to do for the first problem. For the second problem, we want to find the derivative x ln, or we want to find the limit as x. Oh, sorry, I actually didn't tell you what to do here. Sorry, my mistake. What was I thinking? Probably I wanted you to find limit as x goes to 0. Did anyone intuit this, or? Yeah, sorry, my mistake. Oh, you should have asked. You should have asked. If you're confused, there's just as good a chance that I made a mistake as that you're actually confused. That's a shame. I really like this problem. So the way that you do this is you rewrite it as ln x over 1 over x, okay? Limit as x goes to 0. And so then, does the top go to infinity? Yep. Does the bottom go to infinity? Yep. So then take the derivative, you get 1 over x over minus 1 over x squared. And then you get minus x, because we move this up top. And then we're taking a limit as x goes to 0, and that just gives you 0. Okay? Great. So for the third problem, yeah, sorry, I forgot to write what the limits were, because I guess it was just clear in my head, but obviously it's not clear to someone looking at it. So then x to the 1 over x. For this one, I was probably trying to make you do limit as x goes to infinity. So, okay, did people try and get this limit here, or did you do something else? Okay, well, sorry about that. I'll just go over this as though it was limit as x goes to infinity. Yeah, sorry. Also, if you were confused, these are all really good problems because all of them have different methods than like the standard ones that you'll see for L'Hopital's rule. And so ones that have weird methods are great for tests because they're not routine. So I'm really sorry about forgetting to write in the limits, but if you were confused or didn't take the right limit, which is completely not your fault, you should still go back later and try and solve these, because if you know these methods plus the standard ones, that's basically all there is for L'Hopital's rule. I can't think of any other methods. So for this one, it's not immediately obvious how to use L'Hopital's rule. So the only reasonable thing that you can do is, instead of computing the limit as x goes to infinity of x to the 1 over x, why don't we compute the limit, so it's not equal, but why don't we try taking log? So we'll take log x to the 1 over x, lim x goes to infinity. And so then that gives you 1 over x, ln x, limit as x goes to infinity. And so then what we can do is we can just take the derivative, and then we get 1 over x, and then minus 1 over x squared again. Or, sorry, we just have an x in the denominator, so we just get a 1 in the denominator. And then it's a limit as x goes to infinity. And so that gives you, this goes to 0, right? But of course, this is not the actual limit. So call the limit L. So say that this thing is equal to L. What we just computed, oh no, we just computed ln of L, okay? So log of L, and we got that that's 0. So then raising to the e, we get L is equal to 1. Okay? So hopefully that made sense. All right, so that's all that I have for today. Thanks for showing up to section, and I'll stay for a few minutes after section. I'll also post office hours this week, I promise, because I know I've continually forgotten to do that. And so if you have questions that are more immediate than that, though, please just stay after class for a couple minutes. I'll be here. All right.